Hi guys, good to be back with you, and it's great going on Facebook. Nice to chat to you as well. Yeah. So I don't have to be behind the camera all the time. I was chatting to you just now, and I've picked up a couple of things. I'm sure you're seeing them as well. Lots of people have come through with a whole lot of questions. We obviously can't do everyone's requests, but we will pick out the things that we think are most important, and we're going to do this question now. A little bit of wrapping up of organic chemistry that has been a follow-up to the question I did earlier, and then we'll look at an example of electrolysis, and after that we'll hit Casey big time. We'll see how many
Casey, everyone's like, Casey, I can say, hold on, it's coming.
Yeah, we'll do as many as we can.
Yeah, and okay. John, another thing we have to say is, guys, keep helping each other, hey?
Yeah, no, that's right.
Yeah,
for sure.
We've been so impressed.
It's been brilliant. Yeah. It's been absolutely fantastic.
John has been beaming.
Okay, guys, let's get going. The first question that I want to just deal with is somebody's asked, and more than one person has asked about two things. The one is about arenes, amides, and so on. It's not examinable. So don't panic about that. You might see them in like the 2008 paper. You guys don't have to learn arenes and amides. Anything with nitrogen, forget it. Don't worry. Second thing that you do need to be aware of, people have been asking about alcohols, secondary, primary, and tertiary alcohols. I want to just take you through that very, very, very quickly, and then esters. Just a recap on esters. So let's go to the alcohol story, and let's pick it up. Okay, so when we get alcohols, we can get them in the following form. We can get, and I'll just draw a simple one, we can get an alcohol where the O and the H is at the end. Now, guys, have a look here. How many carbons are attached to the structure that has got the OH functional group on it? So we're looking at this carbon, and we're saying how many partners has it got? Well, it's only got one other carbon. It's there. So this is an example of a primary alcohol. If this gets oxidized, it will form an aldehyde. Okay? So you were helping each other about what's the difference between a ketone and aldehyde. You're absolutely right. Somebody responded and said, if you oxidize this primary alcohol, it'll form a ketone. It won't form a ketone, it'll form an aldehyde at least. And that's right. Primary alcohol forms a ketone. Now, what happens if we say, let's not have it on the end, but let's have it, say, the OH group somewhere else. Let's have it in the middle a little bit. So if we just take that same 3-carbon structure, and we put 3 carbons in a row, and we now put the OH. Notice I'm doing O-H. Please make sure you do that. Don't do this. You must show the bond. So that's wrong. You're not going to get marks for that. So please don't do that. You might see it in some people's other exam papers. It was accepted previously. Now they're being very strict. They want it there like that. Okay, so please remember that. Wrong. No marks. Over here, we've put the OH group onto this side. And now look here. What was the question again? This is our functional group. There's the carbon. How many other carbons has this one got as a partner? How many other carbons are attached here? Now look how many carbons there are. There's one. Oh, I want to change that. I want the color a pink color. There's one carbon onto that orange circled one. There's another one. And so there are 2 carbons here. Never leave a hydrogen off. Make sure there are 4 bonds to every carbon. Okay, so this is now called a what? There are 2 purple ones. Look over here. There was only 1 purple one. So we call that a primary 1, 2 secondary. So we're going to call this a secondary alcohol. Secondary alcohol. And if we oxidize that, we will form a ketone. And a ketone will look, guys, just without all the hydrogens in, we'll have the carbonyl group in the middle. So it will have its hydrogens on the end there, like that, but it will have this part. That's a ketone. Okay? So there's your ketone. If this is oxidized, it will form a ketone. Now, what about a tertiary alcohol? Last one, well, you've got it clear. It's very similar to this. It's just going to be different in that hydrogen is going to be removed and we're going to have another carbon there. So let's quickly draw it, and let's put it out over here like this. 1, 2, 3. Put a methyl group. I'm just going to do condensed formula for a minute because it will just help us get away with some time. And have a look here. We circled where, sorry, that was, I've done the wrong thing. I want to put in the alcohol. Okay, so let's circle the alcohol. There it is. Circle the carbon that the oxygen is attached to and ask the question, how many carbons are linked to that carbon? So how many are there? 1, 2, 3. So this is a 1 primary, 2 secondary, 3 tertiary. Okay, like primary school, secondary school, and tertiary education. So this is a tertiary carbon. A tertiary alcohol, at least. Help me. Tertiary.
Tertiary.
Alcohol. I think I spelt it right. Okay, guys, I hope that's wrapped it up in terms of the alcohol story and the difference between aldehydes and ketones as well. Last thing for organic that we want to just quickly look at, and that is the difference between the esterification process. Is there a shortcut? And it's not too difficult. Remember, we said alcohol plus acid will give you an ester plus water. And we do this in the presence of catalyst conc, sulfuric acid. So that's the shortcut to remember. That if you've got the alcohol, and somebody asked to do one that was slightly more difficult. So let's just do one that's a little bit more difficult. Let's take propanol, and let's take the acid as being ethanoic acid. Ethanoic acid. Well, what's the ester going to be? Well, I'm going to leave that for you just to think about for a minute, and let's see if we can get it out. Well, it's not going to be too long, and we're going to see, we'll take the prop from the alcohol, so we're going to say propyl, and this is going to be ethanoate plus water. Now, what's the structure of propyl ethanoate? Well, again, not that difficult to get it. We need 3 because of prop, then do the O, then we're going to do the ethanoate. We're going to do 2 carbons because of eth, the O there for the double bond, and you can see automatically, now I've just highlighted the functional group, so it makes sense to those of you that are watching, so that you can pick it out, that's the functional group. You don't have to highlight functional groups in the exam unless you're told to. I just do it as a matter of habit because I think it's good for you to see and to recognize what they are. And now the next thing you've got to do, you can't leave your answer like that. You've got to put in all the bonds. So you're going to put in the extra hydrogen bonds, and I'll do it as quickly as I can to show all the hydrogen bonding, all the hydrogen carbon bonds, not hydrogen bonds. And there we go. The last thing for organic chemistry, the very last thing that I want to say about organic chemistry is the properties of organic molecules. Remember, the longer the chain is, the stronger the forces between the molecules are. The rounder they are, the less the forces are. You need to know the properties as well as the intermolecular forces. So if you've got strong intermolecular forces, you're going to their properties. Strong intermolecular forces means the boiling points are going to be high, the melting points are going to be high. The viscosity, now remember, viscosity is the runniness. Something that is very viscous is going to be run, it's not going to run very easily. High viscosity doesn't run very easily. Low viscosity runs easier. So we need to be aware of those physical properties and know how they bond together. Okay, now I digressed from that, and I want to just pick up another question, and I'm going to go through it quite quickly because we got a phone call in on this question about from the November 2010 question number 9, and it's not an electrolyte it's an electrochemical cell, but it's not a galvanic cell. It requires us to use energy. And you can see that over here straight away where we've got a battery. So we're putting in energy and we're getting a chemical reaction. So the diagram below represents a cell that is used in electroplating, a tin metal with a thin sheet. So this is an electrolytic cell. Electrolytic. And the process we call electrolytic cell process is called electrolysis. So now what they say can be used to electroplate a tin metal with a thin layer of silver. So we've got tin and we've got silver, and to improve its appearance. And then they ask us which one of them of P or the metal is the anode of this reaction, of this chemical reaction. So what we've got to recognize is what's exactly happening here. What we need to recognize is that we're going to get silver ions in the solution, and they're going to go onto the metal. And that means the silver ions will gain an electron to form silver metal. Okay? Which means that P was silver, this was silver, and it has become silver ions. So the question is, what's happened? It lost an electron. So silver went to form silver ions plus an electron. That's oxidation. And oxidation always takes place at the anode. And what we've recognized is that's the reaction that's happening at P. And so remember, oxidation happens at the anode. And so we can say P is the anode. The way I remember it is that these two, ox, O, and A, are both vowels. Okay, just a memory, a way of remembering in terms of memory. Okay, write down the following. The name or symbol of the element of which P is composed. Well, we've already done it. The symbol is Ag because it's silver. And we know it's silver because it told us that they were plating this metal with silver. So it becomes silver plated. Okay. It was tin. It's now become silver. Write down the name or formula of the electrolyte that has to be used to achieve the purpose. Well, in this bath over here, the electrolyte, remember what an electrolyte is? It's a solution that contains ions. And those ions have to be the silver ions. So this is the electrolyte. It's in the solution. It's a solution of silver ions, of Ag+. So I would write down electrolyte, name or formula. So I would say silver ions. If you want to write down the formula, Ag plus Aq. And just put the Aq there because it has to be in some sort of solution. Right, we're moving on. And I know I'm doing this quite quickly. It tells us that the switch is now closed. Write down the visible changes that occur at the following. Well, this will decrease in mass, decrease in size or mass. It will corrode because what we'll get is silver from here going into solution. And what will happen to the metal? The metal, well, will become coated with silver. And you'll see that silver forming. Okay. The last thing is write down the equation for the half reaction to support your answer in 9.3.2. So we want just that reaction, the reaction happening over there. So what we're going to say is the reaction is as follows. Silver ions do what? They gain an electron to become silver metal. Now, please notice something. I know that on the half reaction sheet, that very big table, and I've got a big blown up one here, they put the reactions into chemical equilibrium, so they have double arrows. But here we're not looking at double arrows. We're looking at a specific reaction, a forward reaction or the reverse reaction. So please don't put the double arrow in. Make sure that for oxidation or reduction, it's a single arrow. Okay. And then the last thing that we've got to, I think it's almost the last question, it says, how will the concentration of the electrolyte, the Ag plus concentration, how will that change during the electroplating process? Write down only increase, decrease, or remain the same. Now, this is a very interesting question, and I want you to think about it. It requires energy to make ions. And so what we do is we don't want to make too many ions. And in fact, we're only making silver ions. So when you think about that, you want to maintain neutrality. So if we increase that, one of those jumps off there, one of these is going to jump onto there. So in fact, what happens through this process, it remains the same. The reason we know that is we haven't got any negative ions. We don't want to upset the balance. The same number of negative ions and positive ions will be in the solution all the time. As one jumps off here, one will jump off over there. Or as one mole jumps off, one mole will jump on there. Okay. Right, you want to coat the metal with copper instead of silver. State two changes that you will make to the above cell to coat with copper. Okay, so now we've got to check out and make sure that we've got the correct cell. The first thing you're obviously going to need to change, you're going to need to change the electrolyte. So the first thing, electrolyte. And now the second thing, which is a little bit more tricky to explain, but I'm going to try and show it to you here, is if you take a look at the table of half reactions, then you'll notice that silver is weaker than copper. Copper is over here, and in comparison to tin, tin is up there. So what we're going to need to recognize is if we've got silver is less reactive than copper. So because silver is less reactive than copper, we're going to need to increase, or we're going to need to change, shall I say, rather say this, we're going to change the potential difference. Okay, won't be an increase, actually be a decrease. You'll change the potential difference of the battery. So those would be the two things that I would recognize. Obviously, you would also need to make sure that you change the electrode. P must become a copper electrode. So maybe that's a more obvious one, but the electrolyte needs to be a copper 2+ ion solution. P must be a copper electrode, and you might even need to change the electrode. Okay, there we go. Now, I know that was just a little diversion, but I wanted to cover both galvanic and electrolytic cells. We're going to go to a break now. After the break, Zelda's up, and she's going to be doing chemical equilibrium Le Chatelier. So hold on, guys. We're going to crack the KC.
Everyone's been asking that. And then also, a few people have been asking, John, where they would like to get this table as well. Would we be able to find one?
Okay,
please?
Very easy, guys. Remember, this is in your data sheet. At the end of every exam paper, there is the table. Table 4A and 4B. You need to work with the one that you're most familiar with. Okay, 4B is the one I like to work with. The reducing agents are on the right. Check out where lithium is, check out where fluorine is. Fluorine should be at the bottom on the left and lithium at the top on the right. Reducing agents on the right, oxidizing agents on the left-hand side.
And then also, John, Melissa says, thank you. It's the first time she's ever understood esterification ever. And and you've done it. First time she's ever understood. Thank you so much, John.
Brilliant. Yes. Thank you. You're great. Remember, we're supporting you. The reason I'm wearing this is not because of the cricket, not because of the soccer, but well done to Bafana and to the Proteas. But we're doing it because we're supporting you. Class of 2011, make us proud. Okay, break now. KC after this. We'll see you then.
See you then. Bye.